Okay, so the article title is Early Expressive Language Skills Predict Long-Term Neurocognitive Outcomes in Cochlear Implant Users. So cochlear implant will be used as CI throughout this presentation. Evidence from the MacArthur Bates Communicative Development Inventories. The purpose of this article. So the purpose of this article was to document the extent to which early expressive language skills, which will be measured using the MacArthur Bates Communicative Inventories, predict long-term neurocognitive outcomes in a sample of early implanted prelingually deaf cochlear implant CI users. So the goal of this study was to actually examine the predictability of early speech language assessments, specifically using the CDI, in identifying CI users, which is cochlear implant users, who may be at risk for poor long-term neurocognitive outcomes. So this article is focusing on what will happen next. So background information that is very important to know going forward within this article. So cochlear implantation is now recognized as the standard care for medically treating bilateral, severe to profound sensory neural hearing losses. Cochlear implants provide deaf children and adults with access to sound by stimulating the surviving spiral ganglion cells in the auditory nerve. So luckily, this has been a new and upcoming item that people that do have severe hearing losses may use, but unfortunately, it still does not give the adult or child the full hearing that they would have with typical hearing. So it is very important to understand what the executive functions actually mean going forward within this article. So I have defined executive functions according to the article. And EFs are a broad cluster of cognitive and emotional abilities, including sustained attention, shifting attention, speed of processing, working memory, novel problem solving, making, and inhibitory self-regulation. So research has shown that a period of early auditory deprivation followed by implantation not only affects speech and language skills, but also has cascading effects on brain regions responsible for the development of a set of neurocognitive skills referred to as executive functions. So in other words, the main focus was not only just speech and language, but this research is now showing that a period of this early auditory deprivation has effects on executive function, which is listed within here. Children who are deaf with cochlear implants and children with attention deficit hyperactivity disorder have reported delays and disturbances within the development of executive function, which goes back to prove this part of the background information. Okay, so now for methods. Of course, we need to know the participants that were in this article and the qualifications to be part of the article. So this study included 32 participants that were children, adolescents, and young adults. So these participants received cochlear implants within the center that the article has taken place. They were also evaluated as part of a larger study of long-term outcomes following the cochlear implantation in childhood. So this was not just the short term of what happens now, but it was what happens going forward. So as we know within the article, there needs to be qualifications to be in this study. So I thought it was important to include this, that the qualifications for this long-term outcome study, the participants were required to meet the following inclusionary criteria. So one must have prelingual, severe to profound, or sensory neural hearing loss, have received their cochlear implant before age 7, have used their cochlear implant for 7 years or more, use a currently available state-of-the-art multi-channel cochlear implant system. So in other words, an updated cochlear implant. They live in a household with spoken English as the primary language. And they have passed a screening performed by licensed speech-language pathologists before testing, confirming no additional developmental, neurological, or cognitive conditions were present other than hearing loss. So only primary. Hearing loss was the only deficit within these participants. So to be included in this current study, participants were required to have the MacArthur-Bates Communicative Developmental Inventories, which you'll be seeing a lot throughout this presentation, which is also known as CDI for short, completed by one parent within the 2.5 years post-cochlear implantation, so after. Demographic variables were significant in this study as well, which includes the chronological age, gender, and family income, which was coded by income ranges from 1 to 10, and race and ethnicity. The family income, 1 being under 5,500 and 10 being 95,000 or more. An important variable in this study included age at onset of deafness. In other words, this is defined as the age at which deafness was identified or an event causing deafness occurred. As we know, an event can cause deafness. Age at time of implantation, interval of time between CDI and long-term, follow-up testing, pre-implant residual hearing, communication mode, code 1 for total communication and 2 for oral communication. The etiology of deafness included unknown, familial, at least one immediate family member also had deafness of unknown etiology, meningitis, Manzini malformation, which is an abnormality of the ear that is associated with sensory neural hearing loss, auditory neuropathy, a variety of hearing loss in which the outer cells within the cochlea are present and functional, but sound info is not faithfully transmitted to the auditory nerve and brain properly. So just to give more of a visual, I have attached the table in regards to the participant demographics and hearing history. So as we discussed, the onset of deafness in months, age at implantation in months, age at testing, pre-implant residual, nonverbal, income level, and then the age at testing years. Okay, and I liked this table because it shows the early post-cochlear implantation visit and the long-term follow-up visit. So the long-term outcome study provided the initial pool of potential participants for whom CDI data were obtained from the longitudinal base. If participants received the CDI more than once during the 2 years following their cochlear implantation, only the earliest data point was selected for analysis. So as mentioned in the procedure section, licensed speech-language pathologists evaluated all study participants and administered the language test in the participant's mode of communication. So going back to the table we reviewed, there was 2 options of the mode of communication, which was total or oral. Early expressive language skills were assessed on average 1.03 years post-cochlear implantation with the words and sentences form, also known as WS, of the MacArthur-Bates CDI. So what is the CDI-WS form? This form is a parent-completed rating scale of early language skills applicable to typically developing children between 16 and 30 months. But it is important to know that this is also valid for children who are chronologically older but may suspect a language delay, and also such children with hearing loss. The CDIWS form is divided into two parts. Part 1 assesses vocabulary with a 680-word vocabulary checklist. Part 2 assesses sentences and grammar. And Part 2 is actually further divided into 5 sections. Sections A to C assess production of regular and irregular words. Sections D to E assess production of multi-word utterances. And parents are instructed to stop at Section C if their child has not yet begun to combine words. So in regards to measures as well, long-term neurocognitive performance outcomes, neurocognitive assessments were administered at the long-term follow-up visit. 5 composite scores were created from this assessment: language, verbal working, visual spatial working memory, fluency speed, inhibition concentration. So composite score for the domains of language, verbal working memory, visual spatial working memory, fluency speed, and inhibition concentration were created by summing the Z transformed scores. Going forward, the long-term neurocognitive questionnaire. Based outcomes: learning, executive, and attention functioning, which is also known as LEAF scale, is a parent-completed rating scale of neurocognitive abilities used to assess executive functioning and related learning skills. So going back, we discussed what executive functioning would be defined as in our background information. LEAF is reliable and valid questionnaire-based measure of executive functioning. Analysis. Within the study, the relation between early expressive language skills and long-term neurocognitive outcomes were based off the completion of the CDIWS, either in toddlerhood or early childhood. These scores were correlated with long-term performance using composite scores of language, which was also discussed prior. Parent-reported LEAF scores were also provided, which we just discussed. So for the results section, I decided to input this table, which is the descriptive statistics for long-term neurocognitive outcome measures. So this gives more of a visual of everything that occurred in the results. So descriptive statistics for CDI words produced for deaf children after an average of 1.03 years of CI are shown. So here on the left is the long-term neurocognitive outcome measures. So all of the assessments are listed, such as the SELF, the PPVT, the performance-based composite outcomes. The participants are in the next column. And then the mean and the standard dev is also in regards to each assessment and the range. So the important note for this table: the PPVT4 and the SELF4 core, the WJ3 pair cancellation, which is over here, TOVA omissions, TOVA commissions, and TOVA response time variability scores are expressed as standard scores. So M would be 100, standard deviation would be 15. Whereas all other performance-based scores are expressed as scale scores. That's just important to know when you are reading this table. The conclusion that is found in the article: the findings within this study suggest that early expressive language skills, as indexed by the CDI, are clinically relevant for identifying cochlear implant users who may be at high risk for long-term neurocognitive delays and disturbances. And that's why the table that was just shown is very important for the conclusion, because the long-term neurocognitive outcome measures were broken up into each assessment and what actually occurred. So these CI users may still be at risk for neurocognitive delays and disturbances long term. And for our last slide, the discussions. To our knowledge, this is the first study using the CDI that proves expressive language skills obtained in early toddlerhood are clinically meaningful and strongly predictive of long-term language and executive functioning outcomes in school-age and young adult cochlear implant users, which was very interesting within the article because it did not just focus on younger children. It had both school-age and young adults. CDI served as a practical, reliable, and highly cost-effective instrument within this study. And although the sample size of the study would be considered small, only 32 participants as we know, the clinical implications for using the CDI as a screening assessment are considerable. Findings do show that the CDI can be used to identify cochlear implant pediatric users who display low expressive language skills and may be at risk for neurocognitive delays and disturbances in long-term development with cochlear implant use. This study is considered clinical significance because it can provide insights into interventions in the future that are specifically designed to target underlying mechanisms of action and to improve neurocognitive outcomes in young cochlear implant users, specifically deaf children who may not be achieving optimal levels of speech and language performance with their cochlear implants even after a long period of use. So overall from this study of what I have taken from it is that the cochlear implant users will still have levels of speech and language performance that do not reach where they should be at long term, even though they do have cochlear implants. Thank you.